The oil supply systems of the N20 engine and the N55 engine are very similar. A characteristic map-controlled oil pump is also used in this case. Here you can see the hydraulic circuit diagram of the N20 engine oil supply. Hover your mouse over the components to display more information. Now you can see the path taken by the oil through the engine via the oil ducts. The oil pump draws the engine oil from the oil sump via the oil suction pipe and pumps it into the unfiltered oil duct. The chain tensioner for the counterbalance shaft drive is supplied by the unfiltered oil duct before the oil arrives at the oil filter and engine oil coolant heat exchanger. The filtered oil duct leads into the cylinder head from here and supplies the camshafts, hydraulic valve clearance compensating elements, the Vanos units, the Valvetronic servomotor, and the chain tensioner for the timing chain. Two ducts branch off from the cylinder head into the crankcase. One leads to the oil spray nozzles that cool the piston crown, and the other leads to the crankshaft bearings. This duct supplies oil to the counterbalance shaft bearings and the characteristic map control valve. A duct leads from the characteristic map control valve back to the oil pump in the control oil chamber. The oil return ducts that connect the cylinder head to the oil sump complete the oil circuit. A variable flow pendulum slide oil pump is also used in the N20 engine. Although the pump has been redesigned, its familiar function remains the same. The difference is that the pendulum slide now no longer rotates on one axis, as was the case with the N55 engine. The slide is now displaced in parallel to allow variation in the volumetric flow. The fuel delivery rate is at its highest when the pendulum slide is at the maximum off-center position in relation to the pump axis, as shown here, because this is when the greatest volume change in the pump cells occurs. If the pendulum slide is roughly centered in relation to the pump axis, only a minimum quantity of oil is delivered as the volume change in the pump cells is negligible. The oil pressure in the control oil chamber pushes the pendulum slide to the right against the spring force. The pressure in the control oil chamber is the same as the pressure in the main oil duct. This therefore results in a control loop, as shown here in the hydraulic circuit diagram. The pressure in the system, and therefore also the control oil chamber, drops as the demand for oil increases. The main spring can now push the pendulum slide out of the center position. The delivery rate of the pump increases until an equilibrium is reached between the spring force and the pressure in the control oil chamber. Move the slider for the oil demand with the mouse, then release the mouse button and observe the delivery volume and oil pressure displays. However, the N20 engine features a characteristic map-controlled oil pump, which is why the system contains two additional valves: the electrical characteristic map control valve and the hydraulic emergency valve. The pressure must also be recorded. This is done by the new combined oil pressure and temperature sensor. The characteristic map control valve is located on the left-hand engine end in the bed plate and is in the oil circuit between the main oil duct and control oil chamber of the oil pump. The hydraulic circuit diagram is displayed here in schematic form. Let's consider the function of the characteristic map control valve first, as the emergency valve is still non-functional. The characteristic map control valve connects the pressure from the main oil duct through to the control oil chamber in the oil pump. The characteristic map control valve can also reduce the pressure in the control oil chamber and therefore increase the delivery rate of the oil pump independently of the pressure in the main oil duct. This, however, does not save fuel, and this is ultimately the reason why the characteristic map control oil pump was introduced. A softer mainspring in the oil pump increases fuel economy. This displaces the pendulum slide towards the center even when the pressure in the control oil chamber is low, which ensures lower pressure ratios in the oil system in general. If a higher system oil pressure is required, the characteristic map control valve can increase the delivery rate of the pump by reducing the pressure in the control oil chamber. The DME can therefore adjust the oil pressure in this manner if required. The characteristic map control valve is normally closed, which means that no more oil reaches the control oil chamber via the characteristic map control valve if it drops out. The hydraulic emergency valve is required, however, in order to be able to limit the maximum pressure and control the delivery rate. It is in the oil pump and is connected to the main oil duct, the characteristic map control valve, and the control oil chamber of the oil pump. When the characteristic map control valve is energized, the piston in the emergency valve is pressurized on both sides. The spring pushes the piston into its end position. The oil from the characteristic map control valve passes through a borehole in the piston and enters the control oil chamber. The hydraulic emergency valve, therefore, behaves passively during characteristic map control operation. If the characteristic map control valve is de-energized, only the pressure from the main oil duct acts on the piston. If the pressure in the main oil duct reaches 5.5 bar, the piston is pushed back and the duct leading to the control oil chamber opens. This pressure is also sufficient to displace the pendulum slide towards the center. This system configuration, therefore, provides a fallback level. This ensures that although the mainspring in the oil pump is softer, sufficiently high pressures will be reached and the delivery rate will still be limited at pressures higher than 5.5 bar. But what do these various pump control systems effectively achieve? If the oil pump is unregulated, the oil pressure essentially depends on the engine speed. When the engine speed increases, the oil pressure also increases. With a volume flow controlled oil pump, the oil pressure initially increases with the engine speed until it is high enough to push the mainspring back and therefore reduce the delivery rate of the oil pump. With a characteristic map-controlled oil pump, the oil pressure can be set more or less arbitrarily, depending of course on the performance scope of the oil pump. Which characteristic curve would you expect to obtain with a characteristic map-controlled oil pump? A pressure characteristic that is generally higher. Roughly the same pressure characteristic. A pressure characteristic that is generally lower. Click on the line that, in your opinion, corresponds to the characteristic map-controlled oil pump. This is unfortunately incorrect. The overall pressure level is lower than the other versions, which indicates the savings potential of the characteristic map-controlled oil pump. The pressure set by the DME depends on many factors: the engine speed, engine load, and oil temperature, for example. The oil pressure can be reduced even further at partial load, for example, which makes further savings possible. The emergency valve limits the pressure to 5.5 bar, which ensures a similar behavior to that obtained via volumetric flow control if the characteristic map control valve drops out. You can try out the characteristic map-controlled oil pump again here. You can specify the oil pressure set by the DME using the slider. To do this, move the slider for the oil pressure specified by the DME with the mouse and observe the displays for the system oil pressure and control oil chamber oil pressure when releasing the mouse. Or simply switch the system to emergency mode. If the pressure rises to above 5.5 bar, the emergency valve opens and limits the oil pressure. Here you can see the hydraulic circuit diagram of the oil supply in the N20 engine. Assign the designations on the left-hand side to the corresponding components in the hydraulic circuit diagram. That is unfortunately still incorrect. What features of the oil pump in the N20 engine are new when compared to the oil pump in the N55 engine? Please select the correct responses. That is unfortunately incorrect. Please try again. That is unfortunately still incorrect. Which components are explicitly required for the characteristic map control? Please select the correct responses. That is unfortunately incorrect. Please try again. That is unfortunately still incorrect. How can the DME influence the oil pressure with the characteristic map control? Please select the correct responses. That is unfortunately incorrect. Please try again. That is unfortunately still incorrect. Three different emergency valve switching positions are shown on the right-hand side. Correctly assign these to the operating conditions on the left. Unfortunately, only some of your responses are correct. Please try again. Very good. All your responses are correct. Here is the diagram that shows the oil pressure characteristic as a function of the engine speed for different oil pumps. Assign the designations of the oil pumps on the left-hand side to the corresponding characteristic curves. Unfortunately, only some of your responses are correct. Please try again. Very good. All your responses are correct.